So let's now continue working on the problems in this review. So here we need to solve an equation with a rational exponent. We can undo a rational exponent by raising both sides to the reciprocal power. So this 3 over 2, we're going to flip it and make it a 2 over 3. So on the left side, that means the exponents are going to cancel, leaving with x minus 3 equals 27 to the 2/3. Now 27 to the 2/3, if you want, you can do that on the calculator. It's 27 caret, and then you do 2 over 3. And then when you hit enter, it gives you the value, which is 9. The reason we get 9 is because this is the x minus 3 equals the square of the cube root of 27, right? So remember, the cube root of 27 is 3. So this is basically x minus 3 equals 3 squared, which is x minus 3 equals 9. So you can now solve this equation by adding 3 to both sides, which gives you x equals 12. And that is answer choice B. So now let's work on the next question. So here it gives you a graph and asks you to select the appropriate model. Notice that this graph very closely resembles a parabola, so the best model to represent this would be a quadratic function. So in this problem, it says analyze the data represented in the table and select the appropriate model. So to do this problem, what we're going to do is we're going to go to Stat and then hit Enter on Edit and enter all of these values into L1 and L2. So I'm going to go ahead and pause the video and give you a moment to go ahead and do that. Okay, so after we've done that, we're going to go ahead and go to second y equals and turn stat plot on so that we can get a visual of what this data looks like. Then you click zoom and choose option 9, which is zoom stat, and you can see that this data very closely resembles an exponential function. So an exponential function would be the best model to represent this data. So now here we have a question where it says a sample of bacteria colonies is growing at an exponential rate as shown in the table. How many bacteria will be present at 8 days? So we have an exponential growth rate. So we're going to use an exponential regression curve to model this data, and then we're going to use that function to figure out the value at 8 days. So we're going to go to Stat Edit, and remember we need to arrow up until the title is highlighted, click Clear, and then Enter. Go to L1 and then go up, click Clear, and then Enter. So we're going to enter all of the day values into L1 and all of the population of colonies into L2. So I'm going to pause the video and go ahead and give you a minute to go ahead and do that. Okay, so now to create the exponential regression, you're going to click Stat and then arrow to calculate and choose option 0, which is exponential regression. Now hit enter and then keep hitting enter, and it gives you the values of a and b that you need to use to write this equation. So we can write this as y equals 56.7 times 1.82 to the x, right? So if we plug in 8 for x, we have 56.7 times 1.82 to the 8th power. So now I'm going to go to the home screen and I'm going to just enter this in to get a value. So I have 56.7 times 1.82, and then I push the caret button and then hit 8 and then enter, and that gives me 6825.8, which is closest to answer choice B. So we're going to have about 6,825 bacteria. Okay, and that is all the questions that are in our review.